Great. So I think we have quite a I think we have an hour and 20 minutes. So
Yep.
I think we have enough time. And if we will have some time left, so I also would like to discuss a little bit some of the pull requests that I did and go over some of the hijinks. Go over some wow, it's some like music recording stuff, or it's just the Zoom background.
You're hearing music?
No.
Oh no.
No,
This is this is a closet under the stairs. No, this is sound insulation. It stops the echoes. It's very echoey under here.
Got it.
Harry Potter box.
So I'll go a little bit over like the first merge request that I did, and like I have an idea for like the first really like even version 0 of the integration that we discussed, and how to implement it without any changes to how currently GitLab infrastructure works, and even without the merge request. So we'll have like very basic fuzzing runs on GitLab with the current infrastructure. So everyone will have like a first feel of this version. So if we'll have some time, and if not, then we'll discuss it in the next meeting.
Yeah, that's perfect. Yeah, and I think that's exactly, I think later next week, Sam's going to walk us through kind of the vision and the different epics of how he sees the product growing. So I think continuing the conversation and kind of your thought process in that meeting will be really great.
Great.
So I think there's a lot of things to go over, and not necessarily the perfect order, but we got to start somewhere.
Great. So I'll share my screen. 1 second. All right.
So I don't know if you guys have seen, there's a channel called Office Today, and it's photos of everyone's office, of what it looks like. And there's some really clever people, like they've got a desk in their bathroom. There's some people that are out on patios overlooking like beautiful sceneries.
Oh, I will have.
I haven't seen that one.
I will have to quit and reconnect because I gave the permission to share my screen, and now I have to reset the Zoom.
Okay, no problem.
Yeah.
There's some pretty interesting office setups.
Are you looking at the channel now, Sam?
Yeah, I'm looking at Lyle's post on May 13th. He's like in the corner of a stairwell.
Yeah.
So I don't see how people sit outside. The glare is always so bad on my screen. I can never like read the screen at that point.
There's very specific situations where I can never get that to work. And then I have to switch all my terminals to, black on white and high contrast.
Yeah.
I find my battery ended up dying like within an hour. Like I can't work not plugged in.
Yeah.
Basically, I have to be in a lot of shade.
Yeah.
Okay. So so I think so I can go, actually I can start from maybe the beginning of how Fuzzit architecture looks like from the high level, and then go through a short demo. I might maybe I did the same thing with some of you, but I will do this again.
Yeah, that sounds great. And I think one of the areas that I'm interested in kind of zooming in on is the database structure, and what is being stored right now. It's in your NoSQL database. So I'm interested in knowing all the different fields, because that's what we'll want to make sure that we design properly.
Yeah, sounds good. So, okay. So I'll go through really the basic overview, because we all know what continuous fuzzing is, right?
Mm-hmm.
Okay, I'll discuss the two main workflows that the developer used for the continuous fuzzing. The first workflow is essentially the fuzzing workflow, and the second one is the regression. I think I talked about it a little bit about I talked about this in the talk that I shared, I think, in the channel in one of the conferences. So it's also mentioned there. It's a talk in Go days. So essentially sorry, it's not this slide. One second. Yeah. So two workflows. So the first workflow, which is the fuzzing workflow, is, let's say we want the master branch. We usually choose one or two branch. We can also choose multiple, but just for the sake of the example, let's say we want our master branch to be, let's say, fuzzed. Okay. So every time a developer will push new code to master, he will build the fuzz targets in the CI. Essentially now it will be GitLab CI, and then we will run them asynchronously, because we want to run them for longer amount of time, and then notify the developer once those one or more of those fuzz targets encountered any new crashes. So of course we'll have to save those crashes, so the developer will be able to reproduce it, and all of those fuzzers, because they are coverage guided fuzzers, probably what we are talking about, like AFL leaf fuzzer, they generate a corpus. So the corpus consists of test cases that help those fuzz tests advance and cover more code paths. So essentially just automatically generates thousands of very good test cases. Just like unit tests, it automatically generates thousands of unit tests that we want to save, because we want to use them later in the later fuzzing sessions or later in the regression sessions.
So a couple questions on corpus. So are those proprietary formats based on each individual fuzzer?
Yeah. So I mean, it's not really, like, most of the fuzzers are open source.
Mm-hmm.
So, but it is proprietary in the sense that, each fuzzer has a little bit different structure, but essentially this is just a directory with files. That's it.
Okay.
Each file is a test case. So that's generally how it looks like.
Okay. So it's a full directory structure. That's organized. Okay.
Yeah. So in Fuzzit, we just zip it. We save it in our infrastructure, and then when we want to rerun it, we download it and extract it back to that proprietary format, but it's just a directory.
And in terms of size of these, are these pretty small, or can these get into the megabytes and hundreds of megabytes kind of thing? Yeah.
So I think usually it's small, because most of the fuzzer they have also something that is called like minimization. It's done automatically. Like the fuzzer usually takes care of that.
Okay.
So he tries to minimize the test case to the minimal test case possible to get to the same code passes in the program. So I would say, like, you can have a lot of test cases. Each test case is small, and maybe everything together. And I need to check for the exact numbers, but I think usually it's kilobyte and maybe something around small megabytes. But of course it depends on the program, because I can, I can intentionally create such a program that will like fool the fuzzer and will create very, very big test cases, but that's not usually what happens.
Okay.
Yeah.
And I think there's a couple of reasons talking about this. One, and James, I know you had written a response to this. One is trying to figure out where to store the corpus within GitLab, whether it's a database, whether it's a file system. That's one item. Another that we're always looking at is application limits, so that, if we have one project, if it's generating, gigabytes or terabytes of data, understanding how we implement limits within GitLab, so that we don't have runaway projects.
Yeah, so I can get back to that. Actually, I think I found a pretty good feature that is already implemented in GitLab. Maybe I'll just mention it now, and then we'll go back to that. There is there is a job API. There is a job document that you have in every CI, and you can store. You can essentially, of course, upload. Like, there is the artifact, and also you can download the artifact that you want. So this is like pretty standard upload download files, which is also used like for binary formats. I think is almost what we need. We'll need some minor changes, but maybe for version 1, maybe it will be good enough.
Yeah, the artifact is great after a job is run. Exactly like you're saying. So a job is run, we can save the corpus. And then I think the question I have, and Jim, maybe you've got some more insight on this, is how do we take that from the job and then persist that so that we can feed it into, if someone runs that job again, we want to get that as the input.
You
it's
can,
that second part I'm not sure about.
You're able to fetch the latest artifacts from a specific branch. So if we make the artifacts not expire, then you should be able to do that for any future jobs on the branch. And if I understand it right, it is branch specific. So if I'm working on my own branch, we'd have to decide, do we always pull from the master branch, or do we always only use the fuzzing corpus artifacts from your current branch? Or maybe if one doesn't exist, then you pull from the master branch and use that for your current branch. Yeah, so like that would totally work. We would just have to make sure they don't expire, just in case the time between fuzz sessions is longer than the default expiration.
And when you said you have to pull it from your current branch, is that a permission issue, or that's just how it's designed?
That's just how it's designed. So I think by default, if you say fetch me the latest artifacts for job X, it uses the default branch. Let's see, I may be wrong on that. Either there is a default and it's the default branch, or you always have to specify the branch to fetch the latest artifacts from.
Okay.
Yeah, so I think that's a perfectly reasonable way to do it. Yeah, it could definitely get us started, and you just chain the build artifacts from one pipeline to the next pipeline.
Got it. And where in GitLab is that? Is that part of the YAML file, or where does that get defined?
It depends. You can pull it down in the script itself. That's what I've done in a couple projects. I could share some examples later.
Okay. Cool.
Yeah.
I have to link to the docs for the artifacts as well. So a couple of the questions might be answered there. One of the points there really jumps out to me is the artifact expiration timer is defaulted to 30 days.
Yep.
So it's not like this would be probably a between fuzzing jobs issue, but as long as we're pushing the corpus to the latest build, I think we'd be good for a while.
Yeah.
So, and actually the way Evgeny, or with the API that he pulled up, I'm using exactly the API and I think the SAS benchmark to pull down the latest build artifacts from benchmark pipelines. And yeah, I think I use the current CI job token for that. Yeah. Anyways,
Okay,
I'll
cool.
share that.
So yeah, that's good. So it sounds like there's a way to, we'll have the artifacts coming out of the fuzzing job, and then when you run another fuzzing job, there's a way to go and pull the previous run.
Yeah.
Cool.
Yeah, I think it should be pretty good actually for the first version. I mean, there are some, maybe I would like more flexibility with this API, but like for example, like somehow specify my own like storage with which is not connected to a job, like maybe provide the seed corpus or something like that. But for that use case, it might work out of the box.
Yep. Yeah, and things like a seed corpus might be something that we can package up as part of, if there's some standard seed corpuses that we can package up as part of GitLab.
Yeah.
But it sounds like we've got some infrastructure to handle what we need to do for at least the initial release.
Yeah. So that's the first fuzzing workflows. The regression. So the fuzzing workflows just I think is so yeah, it's pretty like the standard essentially workflow. And for example, OSS fuzz also they support I think yeah, so OSS fuzz also they support this workflow as well. And the workflow that we also added, some of our users requested it, or maybe we introduced and then they said that they were very happy with that, is the regression workflow. So for every pull request, you run inline in the CI. So you utilize the standard CI infrastructure. You download the corpus. So essentially you download the test case that doesn't crash your target and maybe crashes that you already fixed. You download them into the CI, and then you run those fast tests, fast targets with this with those test cases. So you will be able to check, like to catch new bugs, or you will see, oh, there was this crash that I already fixed and now it happens again. So it just like more very good unit tests and just utilization of the data that you already have for pull requests, and catching things before they are merged into master, which is obviously very good. So just I can show a small example how it looks. How it looks in Travis CI. So Fuzzit is not a CI, so that's why Fuzzit had integration with like a lot of other CIs. So we have I have an example with Circle CI or with Travis CI, but essentially with any CI it will work, because everything we do is we just run the fast targets in the CI with the test cases that we download. So let's go here. So okay, just it downloads some of the stuff, but the important thing is that this is output from libfuzzer, if someone is familiar. So this is so it's running 34 test cases. It usually it's very quick, and then okay, it's success. The program doesn't crash, and the pipeline succeeds, and we can merge the job. If we look at how it looks like in the code.
So what we're looking at here is it's a Go project, right?
Yeah, it's a Go project. I have also the same thing for C project.
Okay.
So it's
Yeah, I just want to be clear that what we're looking at is a Go project that's been instrumented for fuzzing.
Yeah.
Just so that, you know, I think what's important to understand is what the overhead is for a developer in order to implement fuzzing.
Yeah, so that I think so coverage guided fuzzing I think is important. Like there are I would say it's not it's very important for some projects. Okay, like it's a must for some project. It's a nice have for other projects, and for other project it's not necessary. At least I'm talking about coverage guided fuzzing. So I think James maybe shared some of the statistics of OSS fuzz, and I think we kind of saw the same numbers in Fuzzit with regards to crashes. So like fuzzing started from C++ because it's an unsafe language, which was widely used, and still there are a lot of components that are written in C++, which are like core of the internet are built upon, and there are really a lot of bugs, a lot of memory issues, which leads to very serious security implications. So that's like where the fuzzing like started. So there is like AFL and libfuzzer, and at first it was like mainly used towards those languages.
Yep.
So like if I think really if we have projects that are written in C++, probably it's a must for those projects.
Yeah.
Like,
so
at least to have. Yeah. So in terms of what? Yeah. Sorry. Go ahead.
No. So I was going to say, Sam, that might be an interesting research question for us to look at, is what percentage of our customers are running C++, you know, because I think that would be our early adopters on this.
So we do have a report in SciSense about that exact question. In terms of languages we should start with, though, I think Go is actually going to be our best fit because we can dog food it ourselves more quickly. As far as I know, GitLab itself does not use C++ in many places, if any.
Right.
So I think Go would actually be the best technology stack for us to start with.
Yeah.
I'll see if I can find a link to the dashboard about the programming languages, and I'll drop it in the document.
Yep.
Yeah. So yeah, I think we like in terms of some of the statistics that we saw in Fuzzit. So obviously, like it's a must for C++, but actually it was picked. So then and then it was apportioned both like libfuzzer and there is like GoFuzz engine to be used with Go. Not essentially, not Go is a safe language, so it's not to find memory corruption vulnerabilities, but to find essentially crashes and bugs, and so to improve stability in some programs, and maybe even to find like other like logic bugs or crashes. But so for Go projects, I think it might be actually good. A good fit because Go is more popular than I would say C++, at least these days. And we also had more Go users on Fuzzit than people that use like C++, even though it's more needed. There are just more Go projects.
Yep.
And I think it's not a great fit for all the Go projects because, but it's actually a must for some Go projects. So it really depends what is your project is doing. So a good example is, for example, there is also a talk about this, and maybe I also talked about this in the talk that I gave, that there is a Cloudflare. So their DNS parser is written in Go. I think it's some kind of fork of core DNS or something like that. So it's written in Go, and yeah, if you have a crash there, even if it's not security vulnerabilities, then you will have like a denial of service, which is a security vulnerability, and your whole service, which is essentially what your whole company is doing, will be down, right? So you want your like DNS parser, which is external to the world, you want it to be more thoroughly tested with fuzzing. So they use GoFuzz, and core DNS also they use Fuzzit. So this is like a good example for a project that I think it's important to use fastest.
Cool.
And maybe if we like a bad example, or I don't know, some kind of maybe like utility, which is not necessarily like Go utility, which is not necessarily getting some input from the outside world and doesn't have any like security implications, where okay, maybe we'll have a crash, but I mean, what? Okay, you will have a crash. I mean, it's not really like the effort to fast test maybe too much, and also like if it doesn't really get any like raw data, or so not every Go project will be good fit. So
right.
That's, I think, important to understand. We need to find the right projects. Actually, the Go runner might be a good fit. I need to look into this a bit more. If there is some places where it's getting some or parsing some output from an untrusted user, and the Go runner is running on trusted environment, I'm not sure exactly how the architecture works, but if something like that happens, it might be a good fit for dogfooding. Yeah.
Yeah, and I think Sam and I were talking about the runner may be a great project for that, because you can have the runner running in shared environments in a corporation. So if you're a big corporation, you may have a pool of runners, and then each individual project is going to use those runners. So if there's ways for, frankly, a malicious developer to send in bad data to that runner, and that runner can, get access to other data, you could definitely introduce some security problems there.
Yeah, or even denial of service.
I think the runner was one of the places we had talked about potentially being a great place to start in terms of dog fooding and doing fuzzing at GitLab. I guess one thing I also want to add on to the discussion there, because it's great to point out, that C and C++ type languages find bugs in terms of implementation, like unsafe pointers, that type of thing. I think one of the value points we can also really emphasize with fuzzing is the emphasis on business logic flaws, which you mentioned as well, especially once we get into interpreted languages like Ruby, Python. We're not so concerned with finding errors in the actual runtime necessarily, like the JVM in Java, but those business logic flaws are places we can find, meaningful errors and provide a lot of value as well. So I think that's a good distinction to highlight there too.
Yeah, that's right. Okay, so I'll go.
So I don't know if this was helpful. I'd love to take a look if you can walk us through the example Go project and just what need to get done to add fuzzing to it.
Yeah, sure. I opened it and I forgot to walk through it. Yeah, so 1 second. Let's go to Travis YAML. So I have like two stages. So we'll convert it to GitLab stages, and here I have a script, my script that bash script. So what I'm doing here is I'm downloading the GoFuzz library. It's called GoFuzz and GoFuzz build. We can also bake it into the Docker if we want to save this step. And then we call GoFuzz build. So this is essentially builds the target, which is like instrumented with the coverage library, because it's coverage guided fuzzer. So we have to instrument the binary with this additional coverage instrumentation. And then we need to compile it with the sanitizer, and yeah, we need to compile it. So essentially, this is how so GoFuzz has two engines: LibFuzzer engine and like GoFuzz vanilla engine. So here I'm using LibFuzzer engine. So it involves two steps. It involves GoFuzz build and then clang compilation. Like LibFuzzer is part of clang, okay, compiler. So you have to create it, and essentially parse complex. This is like the only binary that you need for fuzzing. So this is the output, and you just need to run it.
And so parse complex is it's referring to your Go project.
Yeah, I can. Yeah, so I can show you maybe how it looks, how the fast test looks like. So okay. I have yeah, 1 second. So I have this code. So this is not the fast test. This is just a function. So it's called parse complex. It's getting an array of data. And like there is a bug here that essentially if it gets the word fuzzy, then it will access the fifth element and it will crash. Okay, so it's not a memory like it's not a memory issue, but because the Go runtime will catch it, but the program will crash.
Right.
Yeah, so like it's a type by one error, but if it will get anything else, then it won't crash and it will just run. And like the idea with this program is to show how quickly a coverage guided fuzzer will find this permutation of strings.
Right.
So to write a target is what you need to write a function that is named fuzz, and GoFuzz or LibFuzzer essentially will call this function thousands of times with different data according to the coverage feedback that they get. Okay, so they know to generate the right data, and then you just pass it to the function that that you want to test. Okay. So this is a simple example. There are obviously more complex functions that you can write depending on your like, because sometimes you don't have just a row of bias data. Sometimes you want to do some transformation to like a structure. So you want to take this random data and turn it to a structure that your function, because your function is not always getting like just an array of data. So okay, and then essentially I call Fuzzit as our CLI tool, which I think we can reuse a lot of the code there, which takes care of like running the fuzzer, taking care of like essentially it's giving one API to run different fuzz targets, different engines, and transform everything to the same format. So our system will be able to nicely integrate with with the output. Okay. And take care of like downloading the corpus from the infrastructure and things like that. So we won't need to write all of those steps in the shell script every time we want to rerun the fuzz target. So here we are doing a create job. So a regression. This is best from Travis. So let's say it will be a regression. Fuzzy dev parse complex is, Fuzzy dev is like the organization in Fuzzy, and this is parse complex is the target. So now our CLI will know to download the right corpus. Okay, because right. Like every target has its own corpus. So we know that parse complex under our account. So we know to download this corpus, and then we run parse complex with the corpus and in the mode that, but essentially, like actually in GitLab, a lot of that is already solved. So because in the CLI, we already have like CI project ID, CI, yeah, like the job ID, which is essentially can be the target, because we can have like for every like every target can be job.
Yeah. So what I'm thinking about when I look at this file is that there's a short-term and a long-term kind of solution. One is in the short term, you've got this shell script that a user adds to their repo. And I think we could do that in the short term. In the long term, if I look at the shell script, there's one value, which is the target, right? Which is parse complex.
Yeah.
So in the long term, we could actually take this shell script and it could be part of GitLab. So if you're running a Go fuzzer, we would be able to have this shell script and then just paste in essentially or interpolate the target name parse complex on line 20, 21, and then 28, so that the user wouldn't even have to mess around with the script.
Yeah, I think yeah, I agree. There is room for more optimization, even though of course this script is pretty short. Yep. And some of those lines are already in the GitLab CI YAML for Go project, because like they build like this Go get and like Go build. They are already, like those lines already exist in those GitLab CI YAML. But yes, it's possible. Yeah, of course. Like parse, this is probably not necessary.
Right.
Because we already have it.
I mean, is this script, could this be version 1 of our fuzzing.yaml template file essentially? Is that kind of what we're talking about?
Yeah, so this is, yeah, we can jump for a second into this. Let's see, I have some it's a bit, my local version is a bit slow for some reason. Yeah, okay, I'll jump to that later. Okay. Yeah, so I'm like the first version, which I thought might look. Can you see my current screen? Right. Yeah. The GitLab.
Yeah, you've got a IDE open and
yeah,
a YAML file open on the other side.
Cool. So like the first version is a test. We can have. I played a little bit with it, but to add another stage here, we can have like a fuzz stage, and so I just need to change it to fuzz, but essentially it can be also in the test stage. It really up to us or up to the user how they. Yeah, I think we want the fuzzing to run after the unit tests, let's say. So we can have another stage, and so I'm downloading the GoFuzz and GoFuzz build. I'm calling GoFuzz build. Here it looks a little bit even easier, but different from the last example, because it's using the vanilla vanilla engine. So GoFuzz build, and then I'm just running GoFuzz. But the last step here, I'll probably will use the Fuzzit CLI, which we will call, we can find a new name for it, GL Fuzz CLI, or I don't know, think of a good name for our fuzzing CLI. So GL Fuzz we will pass essentially the binary that was outputted from GoFuzz build to the GL CLI, and the GL Fuzz CLI will download the corpus using the API. But this will be internal. It will do this behind the scenes. We'll download the corpus and we'll run the target either in fuzzing mode or in regression, depending if it's a pull request, it can automatically detect if it's a pull request and run it with in regression mode, and if it's merged to master, then we can automatically run it in fuzzing mode. So let's say for version 1, we can just run it for a minute or two, or to give a user the option to configure it. And then in the long term, we'll have to configure it as like async or long running jobs or something like that.
I've got a couple of questions from that. Let's see. So let's say we're in fuzzing mode and we're generating a corpus, right? However, we figure out the corpus storage, which I think will totally work using the artifacts. It's a little more complicated, but I think it'll work. But so we've got a normal corpus for fuzzing. The regression data, that's basically, if I understand it right, a corpus of tests that have been known to find bugs in the past. You just run each of them once to make sure there's no crashes, right?
It's either crashes that were fixed or just test cases that were generated and never crashed the program, but they were like essentially LeapFuzzer generates test cases. So let's say you have, it generates a corpus of 100 test cases. So each test case gets the program to new code paths, and this is why it generated
So we need a separate way to store those artifacts as well as the corpus, right?
So the output of most, I think yes, but the output of LeapFuzzer and also GoFuzz is. So, okay, sorry, I don't remember exactly now the GoFuzz format, but LeapFuzzer format is a directory of test cases, which is the
that's right,
the corpus. And
I just realized I'm getting things mixed up. That's why we have the crashes table in the database, and we're not using the corpus storage method for tracking those test cases that cause crashes. Those get put directly into the database. So we can track them, right?
I mean, we can. I don't know what will be the right solution. In Fuzzit, we store the crashes just in also in storage, just in different different path, like another artifact. Like there is corpus.zip artifact and there is crash.zip, just crash.
Okay.
For a job.
So what happens if, okay, so say I've got two separate branches, pull requests or merge requests going for both of them.
Yeah.
And they each generate two different sets of crash data. Does Fuzzit architecture currently store them separately because they're not merged into master, they're specific to the branch?
Yeah, so so in pull request, we don't run fuzzing, we just run regression, right?
Oh, I see. Okay.
And if there is a crash, then yeah, we store the crash in the storage, so we can like download the test case layer, So the person who did the pull request will be able to maybe reproduce or understand what is the issue.
Okay. So Fuzzit, default setup that Fuzzit is currently doing, default branch is where the fuzzing occurs. When the default branch changes, it kicks off another fuzzing job, another fuzzing session. Pull requests only, or merge requests only run regression tests, not fuzzing sessions, right?
Yeah.
Okay.
That's correct.
Okay.
A regression test does not update the corpus. Is that correct? It's just using the
Yeah. It's not update. It's just downloading essentially. Yeah. It's not. Yeah.
Right. So that resolves, James, I don't know if this is kind of what you were thinking, is you have two branches, how do they both update the corpus?
Yeah, exactly. I was thinking that it was just like with the SAS testing, or our other analyzers, it runs on all branches or all merge requests. I was picturing the fuzzing the same way, and if we already discussed that at some point, I may have missed it, and it may not have been apparent to me. But yeah. So that's where I had a little mix up. So that does make the corpus updating and storage quite a bit easier, because then we're only running on the default branch.
Now the one I think question around that in terms of from a user perspective is, and I think in the chat room we were talking about this, is a lot of the issues are, a lot of fuzzing problems or vulnerabilities are caused by new code. So in this workflow, what happens is you have new code, it's on your new branch. We're going to run regression. We're not going to find any regression problems because that's old code that we're testing. We've got new code. We're not going to get additional coverage because we're not running a full fuzz job. That would get merged into master. Then you're going to run the full fuzz job and find the vulnerabilities on default.
Yeah.
That's exactly my follow-up question that I was working towards too. It's is that the way we want to do it? I was thinking the fuzzing as part of every merge request to prevent things making it into master. So
there is obviously always a trade-off, right, of how much resources also you want to consume, also in terms of CPU resources, not only in terms of how difficult it to develop like all the permutations and stuff like that. But the problem with fuzzing the pull request is that also like there is the question, okay, how long do you want to fuzz the pull request? I mean, we can essentially the user can configure it. Okay, let's fuzz things for 1 hour, and then he can do it with the current GitLab infrastructure because he wants to do it inline, right? Because he wants to find the bugs before it's merged.
That is a good point.
But like from what we saw, that like the current this is, I think, the like OSS fuzz in terms of the fuzzing workflow also I think they're also fuzzing only one branch, and for most of the projects I think it's really good enough because we bring the clients that need fuzzing, that their project is like security sensitive C++ or like Go security sensitive, then we give them the ability from not fuzzing is not available at all because it's not possible to do it in current CIs, to we have fuzzing on like one branch, master branch ongoing, we have on pull requests. It's usually like good enough, and like we might encounter that's my guess, I don't know, we might encounter crazy, I don't know, like fuzzing like project that is really into like fuzzing all the possible branches for a long time, spinning, like having multiple versions that are important to be fuzzed. But I think it's very specific use case, then you know, if we meet this
So
client, maybe we can, you know, and he wants to pay. You know, he's a big client, and this feature is really important. Maybe we can add this possibility of like fuzzing multiple branches. It's possible. It's possible to add it.
So I think the way that we should think about approaching this is inside of each pipeline for the merge request, we should do as much fuzzing as we can and let users dial it back as desired. Regression fuzzing being quick is great. I think that we should do that, but you know, we've got up to an hour by default per pipeline. We should be using that hour unless customers tell us not to. It's not going to be a great user experience if we do fuzz testing that we know is not going to likely catch bugs in the new code, and it gets merged into master, and that's really the only place we'll get it because we're doing that more in-depth fuzz testing. Assuming that we can kick this off and get some results in under that hour default time frame, we should do that.
I think another point too is that first off, I agree with that. I think we should be fuzzing, just like Sam said, with the merge request. Related to that, OSS fuzz has totally different goals than us. It is a very similar setup, but they are not a DevOps company. Their goal is only to fuzz the master branch. I'm not going to say their goal is to only fuzz the master branch. They're coming at it from a different direction, and we're situated in a better place to help developers with their new code better than OSS fuzz is. So like, I like the comparisons with us and OSS fuzz, but it's their decisions don't have the same meaning that they do for us.
Yeah, totally. I think yes. So we can add more configurations later. I think I just talked about like the simplest configuration in terms of like first version, if it sounds reasonable to you.
Yeah, I mean, I think this is good. I think we all kind of understand where it's at right now. I'm happy to move on to other items, and then we can kind of figure out whether this is a requirement for our first version or it's something that gets done down the road.
Oh, I had a question about the CLI. What all does the CLI do? I know it launches the process. What does it do in addition to that?
Yeah, so the CLI, I think, is also doing some of the stuff that you commented maybe in our issue. So yeah, it downloads the corpus. In Fuzzit, it also like uploads the corpus. But in GitLab, maybe we can like reuse the like artifact and other infrastructure to output. Also. It gives the developer the option to rerun specific job or reproduce locally. So you can run it from your CLI, from your computer, and it will download the corpus for the specific target. Like you will have to pass like your project ID manually because it's not running in the CI, but the same CLI that's running in the CI now, you can run it locally as well and just pass it the right environment variables like your account token and your account token and like project ID and target name or job name, whatever it is, and then it will download the corpus and it will run rerun the fuzzer and you will see locally the crash. So you can just rerun it locally and see, maybe it will be easier to debug. It also knows to, like, it has two modes. It can, because a lot of developer running Mac and some of the fuzzing engines works only on Linux. So it also knows to spin up Docker locally. and run. So it takes care of like downloading the corpus, like essentially reproducing the same thing that you have in the CI locally at the developer. So just like you run unit tests, the developer might want to rerun it locally before
Okay.
it merges, or I don't know, play with it, debug it.
All right. Awesome. Cool. Yeah, I was curious. Thank you.
Cool. So yeah, so this is like was my idea to try and do the first kind of demo and version with like rewriting a little bit the Fuzzit CLI, which we need like a new name, GLFuzz, or yeah, we need to find a new name as soon as possible. So
Sam, do you want to take that as a to-do, is to figure out what you want to call our CLI?
Sure. I mean, I think GLFuzz is probably a great starting point, honestly.
Cool.
We can use GLFuzz for now until we think of something different.
Yeah, great. So let's use GLFuzz. So yeah, I will rewrite a little bit GLFuzz to work with the like GitLab infrastructure, and to do a short demo with this, and like add artifacts, and then we will be able to run the pipeline both in fuzzing mode and regression mode, and see how it works for version 1. Of course, so, and then to like version 1.1, we'll be adding the merge request that is currently reviewed and saving some of the data and the crash to that database. So then we will be able also to view it in the front end later, and not only in the logs. So okay. Yeah, regression. Yeah. So I think we talked actually. So I'm not sure how. So I can walk quickly through the.
Yeah, I don't need to go through this. I don't know if
Yeah,
anyone else needs to.
Yeah.
I'm good.
Okay.
I'm good without it.
Cool. So let's see. Yeah. So I think maybe okay. There is one more thing. How the like long running jobs looks like. So here, what Fuzzit takes care of is like the asynchronous jobs. So we run them on Kubernetes, and we want to reuse the GitLab runner, because it takes care already of a lot of things, and integration with GitLab, and like logs. So we just want to add the long running feature to GitLab runner, and then in Fuzzit it looks like this. So we have the logs, and then okay, for example, it found a heap overflow crash. So this is like raw logs from libfuzzer, and so we are doing additional analysis like with stack parsing. So we are saving the crash. We are parsing the stack trace, and
if I understand correctly, so you've got the CLI, and it's running the target on a Kubernetes.
Yeah.
And then so it's fuzzing.
Yeah.
And then a crash is generated.
Yeah.
And then the CLI takes that crash and sends it up to, in this case, fuzzit.dev. And then fuzzit.dev is showing this in the web interface. Is that?
Yeah, exactly. The Fuzzit, so the CLI, it knows how to analyze different exit codes and formats of different fuzzers. So we know that like libfuzzer returns, I don't know, 1 for crash, 2 for timeout, and 0 for success. So he knows to take, okay, we have a crash, I know where the crash file is located, and now I'm putting it in Fuzzit format, saving it in Fuzzit storage, analyzing the logs, parse the stack trace, because I know there is a stack trace, and now yeah, saving all this metadata, and yeah, so that's essentially what we will do. Just like there are like the vulnerability lists, we'll have kind of the same list of crashes that we had for each fast target. We'll be able to like resolve it.
And the idea right now is that we would take the CLI, it would send those crashes up to a GitLab endpoint, and then GitLab would store that data in the database.
So my current idea was to at least for the first step, and maybe also later, to reuse the artifact YAML. So there will be like artifact for a corpus and artifact for a crash. So the Fuzzit CLI will just put it in the right path. So the GitLab like infrastructure will know to pick up the crash. And also the Fuzzit CLI, just like the GL JSON, there will be Fuzzit fuzzing report. It will do like GL fuzz report.json.
I was just going to mention that.
And there will be all the data, like the parsed stack trace, like crash or not, crash, timeout, and then we will just put it on the Ruby side, just like in the SAST. We'll put all this JSON data, we'll put it in the database, and then we'll be able to view it in the front end. So,
yeah, no, that makes a lot of sense to me, is to use that artifacts. It'll help us get moving very quickly, and it gives us a lot more flexibility.
Yeah. So the CLI would generate the JSON artifacts. Do we have, that seems to be, I think that would be a pretty, definitely part of the MVC, right? Do we have an issue where we could talk about the structure of that anywhere?
I don't have one created.
We have the issue for discussing presenting the results. So that download report option, I don't think it goes into the actual structure of what's in there beyond let them download it. I think that's probably the place to start that discussion, and it probably will break into some sub issues.
Okay. All right, cool.
And we probably have a good starting point, Evgeny. You've got that, all of that right now goes into Firestore. So it's a JSON, it's a JSON document. So I would think we'd probably take that, wholesale and use that. And then if there's any tweaks, James, that you see on that, that would be a good way of going about it.
Yeah, it will be some permutation from the JSON, from the Firestore JSON. So that's, I mean, that's how it looks like. So like we have for each project, we will have all the fast targets that ran. So like fast targets will be kind of jobs in GitLab, I think, something like that. Like each job is a fast target that can run concurrently, and it gives like very good distinction, I think, in the UI, and we can show results for each, like history results for each target or like job, essentially a GitLab job.
Yeah, so when we think about how we structure the YAML file for GitLab CI, I would see this a little bit different than what we have today with the security jobs. For example, in the security jobs, we have a DAS template, and it has all the values, and you can have some parameters. We could do that for fuzzing, but then the problem is all your jobs are called fuzzing. One of the ways
sorry, go ahead.
No, I was gonna say, and maybe this is one of the ways we could do that, is we set up fuzzing as a job or whatever, And then when you set up, let's say it's CSV or GIF or whatever, it would just inherit or grab all the values from the fuzzing job. And then that way you've got a job called CSV or GIF or OpenSSL or whatever, but it's using all the template values that GitLab pre-packages up for you.
Yeah.
Why would it be a problem if they're all named fuzzing? Because wouldn't that be in context of an individual pipeline? So there wouldn't be more than one fuzz job running?
So I'm not sure I understood, but like what I thought of is there is like a master template or whatever or a stage that we do fuzzing, and then we have for each target we have a job. So there is like fuzz heartbleed, fuzz HTTP response. So essentially each target is usually a function or a test. So we'll have like for each fuzz test, we will have a separate job, which the user can call just with the name of his like unit test function, which is, I don't know, if he's fuzzing function 1, so it's like fuzz func 1, fuzz func 2. It will be like jobs in the same stage. So I'm not sure if I answered your questions, Sam. You can ask again.
Yeah, not quite. I think we're probably overload, or at least in my mind, I'm overloading some terms. When I'm saying job, are we talking about jobs in a GitLab pipeline, or are we talking about jobs that would run in the Fuzzit backend infrastructure?
So I'm talking about job, like I think I'm talking about both, because I'm talking about about the job in GitLab. So each job will run each job will run a separate fuzz target. So
so if you go back, you're going to the example Fuzzit project you've got, your third tab, I think.
This one?
Yeah, sorry, go back to the Go code.
Yeah.
So my understanding is, for example, if you have a Go project, really simple Go project, you've got 3 functions, right? Those are going to be 3 different targets.
Yeah.
So it's not one fuzzing job. Yeah. It's not one fuzzing thing. You're actually setting up 3 different calls. So in this case, you would have parse complex, parse simple, parse complex. So you have 3 different targets. And when we convert that to GitLab speak, that would be 3 different jobs.
Yeah.
One job for one target. So we don't want that job to be called fuzzing, because it's not really fuzzing. It would be,
exactly.
Be fuzz, parse complex, fuzz simple, fuzz super complex. They would all use or inherit from our fuzzing template, which would give you certain, boilerplate, if you will.
Got it. So it's an individual job on a per target basis, rather than the individual targets being fanned out from one job, one parent job.
And target
that makes sense. I think that's.
Go ahead, keep going.
That makes sense. I think that's going to be really tricky from a user perspective in how we want to present that info. Imagine if we're fuzzing like GitLab, for example, and we have 200 targets detected. I don't know if GitLab today we have some mechanism. I know we have child-parent pipelines, but we're going to need to figure out how we present this to users without overwhelming them in terms of the number of jobs that get created. Because I can see it becoming pretty confusing if your pipeline has 4 jobs in it that you defined, and all of a sudden it has hundreds or dozens in the actual pipeline result for you. Does that make sense?
So I think sorry, go ahead.
The child pipeline method, we could dynamically generate child pipelines for every target. So the user would define, that they would have one job to build their fuzz targets, and each target is, in my mind, all it means is separate binaries to run, right? However they set it up, it's up to them. And then they could specify in a variable, like a directory full of target binaries, and then we could dynamically create a child pipeline that spits out a new job for every binary in the pipeline, and then name the job after the binary name. So it's easy to figure out which one is which. And then we would have to have a separate job that waits for the child pipeline to finish and merge all the results together. I think we could totally do it. It is, but yeah, that's my first thought. I'm making it so the user doesn't have to explicitly define 100 separate fuzzing target jobs.
Yeah, yeah, actually auto generating some of the jobs can be good optimization. I think a good note here is that unlike unit tests that you have, like usually unit tests probably like everywhere, like this is how unit tests works. You have thousands of unit tests with 2 lines of code, and every time you add new code, you are copy pasting all unit tests and adding another test for like for your code, or like you have a lot of unit tests. But I think in the fuzzing, you don't have, like, every project that that I saw on the internet usually have a really like couple of fuzz targets. Some I saw also some big projects with like 30, but that was extreme. Like I think systemd has like 30 or 40 fuzz targets, but this is, I think this is the most, like the project, like the biggest project with a lot of fuzz targets that I saw. But most of them have really, like, let's say up to 10. Okay, and maybe even less, because essentially each fuzz target generates a lot of test cases for you, and like every fuzz target is a lot of unit tests. Okay, we can think of it like this, and this is why we have much less like fuzz tests in the project. So so I think from user perspective, yeah, it will be good to kind of like have some way of showing maybe, or like minimizing the number of jobs, or like expanding, but we'll even in the beginning probably it won't add like hundreds of fuzz targets for a project.
Sam, related to this, when we've talked about automatically extracting the fuzz targets from the unit test, there's we would have to deal with having too many jobs. Okay, say we extract 100 different jobs, and this is definitely not MVC, right? That's 100 hours worth of CI if we have each of them run for an hour. So I think we would have to have a different approach for fuzzing individual functions extracted from unit tests. Anyways, yeah. But I agree with you, Evgeny. Normally, when you're fuzzing a library or a code base, there's like one main entry point, maybe a couple that you send. It's the main attack surface that you fuzz. So the general use case, yes, there's not tons of different targets.
Yeah, no, that's understood. I think the point of concern I'm raising is, from our perspective, since we know what fuzzing is, we're thinking in terms of targets. In terms of where our customers and our users are going to be coming from, they're going to be thinking in terms of their app and their code base as a whole. They're only going to be thinking in terms of, I want to do fuzzing, full stop. They're not going to think about, well, I need to make one fuzzing job to test this aspect of my app, one fuzzing job to test this aspect of it. If we can shift our thinking when we're coming up with solutions to look from that angle, I think that will get us a better result. A pitfall I can see us falling into, if we think about it from the more fuzzing expertise angle, is it'll make sense if you already know what fuzzing is in terms of having many different targets and jobs created, but our end users that don't have that context might get lost in following with us. Because yeah, the point is well taken. We probably won't have hundreds of targets for any specific thing. But where I would ultimately like us to be at is we have one fuzzing job, which then users could drill down into, and then maybe it fans out to the many different targets, or even 3 or 4, rather than putting that initial burden of understanding on them from step 1. Does that make sense?
Yeah. If we're using the CI or the CLI to launch things, we can have that control how long each individual target runs for within a job even. So it is boxed within a job, and then we just collect all the results together.
James, you
I think
mentioned,
that'd be a great place to end up at.
James, you mentioned child parent pipeline. So
Yeah.
where do you create a child pipeline? Is that
Okay. I've had a lot of fun with this lately. Maybe a little too much fun. So I've wanted this feature for years, so I'm like super excited about it. But so you can have one job that dynamically creates YAML, and then so it has to be in a separate stage, or not separate stage. That job needs to come before the next job, which is a trigger job that points to the previous job's build artifact. So it says, take this file from the previous job that was generated and run it as a child pipeline. And then you can tell it to depend on that child pipeline, so it blocks. And then you could have another job after that that then goes through and collects all the build artifacts from the child pipeline. Yeah.
got it? So you have, I guess the gist of it is you have a job that creates YAML that will be read as a new CI file in a sense.
Yep, exactly.
That's cool. That's cool.
Yeah.
Got it. So theoretically,
benchmark does that too.
So theoretically, we could have like we're saying, we could have a fuzzy job. It could just do some homework, so to speak. It does some homework, and then it doesn't really do anything. But then it creates a whole YAML file of everything that needs to get run.
Yes,
Yeah.
we could. We would have a problem with, say worst case scenario, thousands of targets. That's instantly thousands of jobs and hours worth of compute time, right? But that's worst case, somebody wanting to mess us up or something. Just something to be aware of when we're dynamically creating jobs.
Cool.
Well, so maybe that speaks to, we need to put not a fail-safe, but an upper bound and say, my appetite for this fuzz job is 100 CI minutes per run, and then restrict ourselves within there. Because yeah, James, to your point, it wouldn't mess us up if they spawned off hundreds of jobs, but their bill would go through the roof, probably
Yeah, exactly.
unexpectedly, right?
Yeah.
Cool.
We should probably put an issue together for that if we don't already have one.
So I know we're coming up on time here. We've got about 10 minutes. This is I think been exactly what I'm looking for, is this kind of discussion and figure these things out. Anything that anyone else wants to cover today? I feel like our next session next week, we can continue where we leave off today.
If possible, I would, let's see, I know Evgeny is working on a proof of concept for the fuzzing using the build artifacts. Is having fuzzing, it sounds like having fuzzing in every merge request is something we want. I'd like to help get that into the proof of concept. I think there's a very easy way to have a global corpus store tied to the master branch using just build artifacts so that we can get it into the proof of concept. Is that, do we agree that's something that we should try and get?
Yeah, I think, yeah, sorry. Okay, yeah. Yeah, I thought
no, that's perfect. Yeah, that's perfect. And I guess the question that maybe we could spend the last couple minutes is, what's the best way to collaborate on that and work together to do that? We have the, oh man, I named it so many times, the Fuzzing project, which everyone's been added to, which is
You're talking about the Fuzzit private one?
Yeah, it's gitlab.com/gl-fuzzing. Evgeny, it looks like a lot of the work you're doing is local.
Yeah, so I just started like today because like I knew I mean yeah. Yeah, I worked on the merge request on the database because that's what we wrote in, and then I started working literally today on the transforming the Fuzzit CLI to like GitLab to work with the GitLab infrastructure. So I can open a new repository, which we can make private for now. I think, I don't know, private public. Yeah.
it doesn't really matter. Anything in GL-fuzzing is just for us. So I believe, James, correct me if I'm wrong, even if it's a public project, people don't have membership into GL-fuzzing, so they wouldn't even see it.
You can't have a child project with greater visibility than the group. So everything within GL fuzzing is private. I've tried and learned the hard way. Yeah. So. Yep.
So yeah,
there was a CTF challenge about that actually.
DTF.
CTF,
Oh,
the
CTF.
capture the flag. There was a group permissions exercise in it.
Ah. That sounds great, Evgeny. If you have create a new repository where we could create a proof of concept and hash out that GitLab CI.yaml, yeah, I can help make merge requests. We could talk about it, work things through. I can comment on your stuff.
Yeah, awesome.
Yeah.
Awesome. So I'll add it to those. I will add like an example repository. So let's say we set Go, so we'll work like with the example Go, and I'll also add the repository of the GL fuzz, and I will do essentially two branches there. There is the master branch, which is currently working with Fuzzit, and I opened the new branch, which will be GitLab branch, and then when we will publish it, there will be just like we'll push the GitLab branch to the master, and it will be only this branch. So I will push those two repositories. Hopefully by tomorrow, I'll do some minor like cleanup and homework, yeah. So you will be able to see it and comment.
Sounds good.
Sounds good.
Cool.
Perfect. Sounds good. And then I guess we'll just put a bookmark where we're at today, and we'll pick up next week and keep going through some more of this.
Sounds good.
Any other departing thoughts?
Thanks so much, Evgeny. That was very informative.
Okay, thanks.
Yeah.
Yeah, very good walkthrough. Really appreciate it.
Thank you. Okay. Thanks. Talk to you soon.